In this video, we're going to discuss the quadratic function in vertex form. And we're going to break it up into two short videos just to make this quick. I want the videos to be quite terse so you don't have to waste too much time. So the quadratic function in vertex form. So the equation for this is y equals a bracket x minus p squared plus q. So we call this the vertex form because you can read the vertex of the parabola right out of the equation. So the vertex is given is the p comma q. Now note that it's the opposite sign here. So it's actually just the p value. So if you had something like x plus 2, p is actually negative 2. Now, we are going to observe how a simplified form of this works, just so we can kind of get the grasp on how all these different uh, numbers impact it. So the vertex is p and q. What is a? So let's say we had a very simple form of this, which is ax squared. Now, we want to observe, let's say, y equals 2x squared. So I'm going to draw a graph. Let's draw the graph right here. This is y, this is x. So our vertex here, it's hidden, but q is 0 because it's not written, and so is p. So we actually have our vertex here. And the pattern for quadratics is you go over 1, up 1, and over 1, up 1, and then you go over 2, up 4 for a equals 1. Now a equals 2, so we're going to have to change that. So it goes over 1, up 2. And the same over here. So now we do the same. That's 1, this is 2, that's negative 1, negative 2. So if we have 2, if we put that in there, we have 2 times 2 is 4 times 2 is 8. So it's going to be way up here. And now we'll have the same up here. And we'll fill this in. And now we'll go like this. Okay, so this is y equals 2x squared. Well, what happens, let's say we have another graph, and let's say we have y equals 1 half x squared. So in this case, the x value is halved. So here it was doubled. We went over 1, up 1, but we double it, so we went up 2. So if we go over 1, we're going to go up half. If we go over 2, we're going to go 2 times 2 is 4, divided by 2 is 2. So we go up like this. We even go over to 3 and negative 3. 3 will show us 3 squared is 9. 9 divided by 2 is 4.5, and that's not even that high. That's somewhere like here. So we fill this in. And what we find is that when the a value is bigger, it kind of squishes it down. And if it's smaller, it kind of flattens it out or stretches it out. And that's kind of what we're going to be observing. So this also has the property that a is always positive. So here a is greater than 0, right? And if it's greater than 0, then, so let's say if a is bigger than 0, then it opens upwards. Okay, so now let's say we want to see what happens when we have a negative x squared. So we'll draw another graph. Oh, let's do that there. So if it's opening upwards and x is squared, it's going to go down. So if x is 0, y is 0. If x is 1, y is negative 1. The same over here. And then if x is 2, it's going to be 2 squared. I know I'm just throwing these numbers out, and it probably sounds insane. But we're just kind of trying to observe what's happening rather than worrying about the actual arithmetic. So we find that it opens downwards like this. So if a is less than 0, then opens down. And that's good.